Welcome to a video on solving equations using multiple steps. There was a previous video that discussed how to solve one-step equations. Let's go ahead and take a look at how we're going to approach this. Here are the steps we'll follow to solve equations. Step 1, we'll use the multiplication principle to clear any fractions or decimals if they are present. Step 2, we'll remove any parentheses by using the distributive property, again if there are parentheses. Step 3, we will add and subtract as needed to get all variable terms on one side and all constant terms on the other. Step 4, we will multiply or divide to solve for the variable. And then step 5, we'll check our solutions. So let's go ahead and give it a try. Number 1 here, there's no fractions or decimals. Step 2, there's no parentheses. Step 3, we will isolate the variable term. So what we'll do here is subtract 7 on both sides. That will leave us with 3x equals 36. And the last step, we need to undo this multiplication. So we'll divide both sides by 3. And we have our solution, x equals 12. So to check this, 3 times 12 would be 36 plus 7 equals 43, and it checks. Moving on to number 2, again, there's no decimals or fractions, no parentheses. So the first thing we do is to isolate the variable term. We add or subtract. This is a positive 4, so to undo the positive 4, we will subtract 4 on both sides. This will leave us with minus 2x or negative 2x equals 6, since that simplifies to 0. And the last step, since we are solving for x, we'll divide by a negative 2. Now again, the reason we're dividing here is the negative 2 is attached to the x by multiplication. So now we simplify. This will give us x, and 6 divided by negative 2 equals negative 3. For the sake of time, we will not check this one. Moving on to number 3, we do have a fraction involved. It is optional, but we will clear the fraction. And the way we do that is we're going to multiply every term by what would be the common denominator. In this case, this would be 4. So let's first rewrite this. So we're going to multiply both sides of the equation by 4. So you can think of distributing on the left side. Notice the 4's here would cancel. We have negative x minus 36 equals negative 20. So the idea here is this equation is easier to solve without the fraction involved. So next step, we'll add 36 to both sides. This would give us negative x on the left side, and the right side we'd have positive 16. So if we divide both sides by negative 1, we would have x equals negative 16. Okay, on number 4, we have decimals involved. Well, in order to eliminate the decimals, what we can do is multiply everything by 10. Remember, if you multiply everything by 10, you move the decimal to the right one place. So the result would be an equivalent equation, and that equation would be 43 equals 15x minus 50. And then we follow the same steps. We will isolate the variable first by adding or subtracting. In this case, we'll add 50. This would give us 93 on the left equals 15x on the right. Divide both sides by 15 because this is attached by multiplication. Simplifying, we'd have x on the right, and on the left we have 93/15. Now this does simplify. 93 is the same as 3 times 31, and 15 is the same as 3 times 5. So this would simplify to 31/5. Now since the original equation was in decimal form, we may want to write this as 6.2. Those answers are equivalent, but again, since the equation was in decimal form, we may want to leave our answer in decimal form. Let's go ahead and take a look at a few more. Now before we start to solve this, we can see that there are some like terms on the same side of the equal sign. So let's take a look at the left side first. 8x minus 10x would give us a negative 2x plus 7. And on the right, we have two constant terms, and 10 plus 12 would give us 22. So on the right side, we have 22 plus 3x. Now what's different about this equation is we have the variable term on both sides of the equation. Well, if our goal is to isolate the variable, of course it needs to be on one side. So we either need to subtract 3x on both sides or add 2x on both sides, depending on what side you want the variable to be on. I'm going to go ahead and add 2x to both sides. So on the left side now we have 7. On the right side we have 22 plus 5x. So since x is on the right side, we know when we finish we want to have something in the form of some number equals x. So the next step is to isolate the variable by adding or subtracting. So we'll undo this positive 22 by subtracting 22 on both sides. This would give us negative 15 is equal to, that's 0, 5x. Let's go ahead and rewrite this over here. The next step will be to isolate the variable by multiplying or dividing. It's attached by multiplication, so we need to divide by positive 5. Result will be x, or 1x on the right side, and the left side we have negative 3. So our solution is x equals negative 3. Now in number 6, the first thing we'll do is clear the fractions. So what we can do, there's a couple ways to approach this, but the most obvious one might be to multiply both sides of the equation by 3. And notice how what happens here is this 3 simplifies with this 3. So we're left with 2 times 6x plus 1 is equal to 18. And I could have multiplied by the reciprocal 3 halves, but I'll go ahead and leave it in this form. Now we'll clear the parentheses. So we have 12x plus 2 equals 18. Again, the next step is we undo the addition or subtraction, so we'll subtract 2 on both sides. And I'll write the result up here. We'd have 12x on the left, that's 0, and we'd have 16 on the right, dividing by 12 on both sides. Again, we're dividing because that 12 is attached to the x by multiplication. So we have x equals 16 twelfths, but this does simplify. Remember, we can write 16 as 4 times 4, and 12 is 4 times 3. So we'd have 4/3, or 1 1/3, as our solution. Let's go ahead and take a look at one more. First thing we notice, there's no decimals or fractions, so the next step will be to clear the parentheses by distributing. Next step is we'll combine our like terms. Again, we have x terms on both sides, so we need to get the x terms on one side. So we either need to subtract 5x on both sides or subtract 3x on both sides. I will go ahead and subtract 5x on both sides. So we have to divide by negative 2 to isolate the variable. This would give us 1x, or x, and on the left we'd have 24 divided by negative 2, which is negative 12. I would like to pause now and go back to the first example and show you how you can check this on the graphing calculator. On number 1, we said the solution was x equals 12. So what we can do is assign 12 the value of x on the graphing calculator. So we type in 12 store x, enter. And then what we can do is type in the left side of the equation, 3x plus 7, and see if we get 43. And we can see that checks. Let's go ahead and try number 2 as well. We'll store negative 3 in for x. Negative 3, store x, enter. And then we'll type in the left side again, 4 minus 2x, and see if we get 10. And so this is a very nice way to check your work as you solve these equations.